All right, so this one, it gives you the differential equation, a blank slope field spot. We've got three different parts of this problem here. So I want to show you guys, like I said, where the points are all coming from. So this is what the slope field should look like. So compare yours to it. And like I said, there's three things that they're looking at. The slopes that are 0 should be 0. So you can see over on the right-hand side, it tells you where the points come from. So 2 of the 9 points are from part A. 1 point is for the 0 slopes, meaning the x-axis and the y-axis are both supposed to have slopes of 0. So if all 3 of these points and these 3 additional points right here have slopes of 0, then you get 1 point for that. The non-zero slopes are looking at 2 things that I mentioned the other day. The correct positive or negative direction that they're supposed to have, and then kind of a comparison of steepness. So for instance, these ones in this line are supposed to be less steep than the ones in these lines. The ones over on the left are supposed to be positive. The ones over on the right are supposed to be negative. As long as those things are true, like I mentioned, they're not gonna like break out a ruler and be like, oh, that looks like a slope of 3, not a slope of 4. As long as they are comparatively, steeper or less steep, and if they're correctly positive or negative, then you are good. Okay, so this one, a point for all the non-zero slopes, as long as those 2 things are true. So any questions on the setup of that slope field? All right, part B, I think a lot of people made this more difficult than it needed to be. Tangent line was the y minus y1 equals m times x minus x1. They hand you the ordered pair. They give it directly to you. It says up here, f of -1 is equal to 2. They mention it again later that f of -1 is equal to 2. So when they tell you that you're using a tangent line at x equals -1, this tells you that the y value at -1 would be 2. And then dy by dx, remember, represents the derivative, and the derivative is the slope for your tangent line. So they give you this formula right here. They mean for you to just plug in the -1 for x and the +2 for y. It reduces down to 2, and that gives you your slope. So you can see for part B, they first plug in the ordered pair that they give you, and that gives you the slope, and then just sub it right into point slope form. There is no need to reduce it down to y-intercept form, like the mx plus b. If you do, and you do it correctly, they will not mark you wrong, but it's kind of like, y, if they're totally cool with you just leaving it like this. So just the y minus y1 equals m times x minus x1. Everything just subs in there, and you can just leave it. With a 1 point situation like that, you guys know on my test, I give half points. They don't do half points. So like this equation is either right or it's wrong. It's like 1 point or 0 points for part B. So out of 9 points, we've only given away 3 of them so far. The remaining 6 points are all on this differential equation. So knowing how to do those is going to be the most important aspect of one of these types of problems. So I'll walk you guys through where each one of these points comes from. So separating them correctly, and if you had y to the -2nd instead of 1 over y squared, that's totally valid as well. And then I think most of you probably left the -1/2 on the right-hand side rather than moving it over to the left. You'd have to be careful if you did move it over to the left to make sure that it ended up in the numerator. But I wouldn't do that anyway because you're eventually trying to get the left-hand side by itself. So I would keep everything except the y stuff over on the right-hand side. So if you separate correctly and you have this or something, if you had y to the -2nd on the left and you had -1/2 x on the right, that's still correct. It's just a different way of writing it. So they're not going to write every single possible different way that you could write the same thing. So if you have that, that's 1 point, separating correctly. This next line technically gives you 3 points, which is a lot of points on one problem. So you get a point for -1 over y, which is the same as -y to the -1st power. You get a point for -x squared over 4 or -1/4 times x squared. And then you see right here the constant of integration, that's the c. So you get a point just for remembering the plus c. All right, so this line right here is technically worth 3 different points. The antiderivatives are 1 point each, and then the plus c is its own point. Using the initial condition means subbing in the -1 for x and the 2 for y. So like actually subbing it in at all will get you a point, even if you don't necessarily do the work correctly from that point on, but just using it will give you a point, and then solving for y correctly. So eventually getting yourself down to this point. Notice they have this right here or this. I'm assuming most of you just left the fractions if you got to this point correctly and probably didn't think to multiply top and bottom by 4. And this is them showing you that that's totally fine, even if you just left it with fractions in the denominator. But if some of you guys, really like to simplify things, then you could have definitely multiplied top and bottom by a 4, and that would have cleared out the fractions in the denominator. So either one of these is a totally valid answer. They got c equals -1/4 because they solved for c before they got y by itself. So a lot of people ask me like, oh, what's the value for c? The value for c is different depending on when you solved for c. It's the equation at the end that should always be the same. But when they solved for c right away, they came up with -1/4. I'm assuming if you guys save c for last, you probably ended up with +1/4, or depending, on exactly what point you solve for c. They, on the AP guidelines, will always solve for c first, and then rearrange the equation and solve for y. But like I said, as long as the equation at the end is right, then any order is totally fine. Okay, I want to show you the scoring guidelines again really quickly. So it says you can get a maximum of 3 out of 6 points if you forget your plus c. So if you don't have plus c, you're going to miss the point, where you write plus c. You're going to miss the point where you sub in the initial condition, because if you don't write a c, then you wouldn't be able to solve for c. And then you're going to miss the point where you solve for y, because even if you solve your equation without the c, you're not going to get the right equation without having the value of c. And then you can't get a single point if you don't separate the variables. Because if you don't get the first point, you're not going to be able to get any of the points that come after. So this is, kind of a really unfortunate setup, I guess. But as long, you guys are separating correctly, I think. As long as you remember the plus c on these problems, you should be okay. So any questions on this first one? Okay. I mentioned to you guys, this problem is pretty common. It's almost always number 6, which is the last one. And a lot of people feel comfortable with these. They kind of finish off the test being like, yeah, I'm really great at calculus. Sometimes it's number 5, but it's always on the non-calculator section. Question 6 and 5 are on the non-calculator section. A is always create your own slope fields like this. C is always the separable differential equation. Part B changes from problem to problem. So you've seen this one. Sometimes they do a tangent line. We saw the problem that we did together on Friday, which was the describe all points in the plane that have a slope of -1. The next one did something similar, describes all slope or all points where the slope is positive, I think is what the next one did. So they've got a couple of different part Bs that they will use, but part A and part C are very consistent from year to year. All right, any other questions on this first problem? Okay, is the next one the x to the 4th one?
Yeah.
Okay. This one, something came out weird. I must have forgotten to save this one as a PDF, but I don't know what was happening here. So here is your differential equation and the setup. So this part B is saying describe all the points where the slope is negative. So this is what your slope field should look like. They give you, I have no idea what was supposed to be happening here. There are 2 points. It looks like there's a 1 hiding in there. 1 point for a 0 slope when x is 0 or y is 2. So as long as every point all along the y-axis, and then when y is equal to 2, as long as you have those. So slopes of 0 all the way up and down here, slopes of 0 across here. If you have that, you would get 1 point. The second point, it says positive slopes where y is bigger than 2, and then negative slopes where y is less than 2, with the exception of x is equal to 0. So you've got these 4 down here are negative slopes. These 2 up here are positive slopes. As long as you're good on that, then you'll get your second out of the 2 points. And you can see they're very consistent. So you guys will get to the point where you know these scoring guidelines so well that even if you look at a problem and you're like, I have no idea how to do this part, you'll go well, this part would have been 2 points, this part would have been 3 points, so I'm only you'll be able to kind of figure out how many points you'd be missing even if you don't know how to solve a problem, which I'm hoping you won't be in that situation where you have no idea what to do, but we never know. Part B. I don't know if many of us got this part, but you need this part as well. Because if x is equal to 0, the slope would be 0, not negative. So you'd have to have both pieces of that. And like I mentioned on the previous problem, each one of these individual points is all or nothing. So unless you had both of these aspects of the answer for part B, then you wouldn't have gotten the point. So I think most of you guys had that y was less than 2, but you'd have to exclude anywhere where the slope would be 0. All right, and then let's walk through our differential equation. 6 points again. The 6 points are the exact same as they were before. So this first line, if you separate it correctly, that's 1 of your 6 points. So the y minus 2 should go as an entire quantity off to the denominator on the left-hand side, and then you have x to the 4th on the right. The antiderivatives, you get 1 point for the natural log of the absolute value of y minus 2. Without the absolute value, you don't get the point. 1/5 x to the 5th gets you a point, and writing the plus c gets you a point. So this is like on any AP problem in the free response section, this is where one line will get you the most points. This is the only single line on the AP test that will get you 3 full points, which is a lot in a problem. Next line. So all of this separation stuff really essentially ends up giving you 1 point. Like using the initial condition is subbing in the point, and it looks like they did a couple things to simplify here. Oh, that's weird. They actually, they got y by itself first. They normally don't do that. Nope, they did like a little bit of each. They started to get y by itself, and then sort of in the middle, then they subs the value in. So really, whenever you want that to happen, I think is going to be fine. So exponentiating right here, if you exponentiate the left-hand side, it drops the natural log. When they exponentiated the right-hand side, you can see they did that whole power trick where this is then e to the c times e to the 1/5 x to the 5th. And then they designated a new constant. So they dropped the absolute value by making the right-hand side plus or minus. They designated a new constant to represent the old constant. You don't have to do that. They will be totally fine if you just leave a c all the way through the problem. So it looks like then, kind of in the middle of this, they subbed in their initial condition of 0, 0. And you could sub in 0, 0 right after you integrate. You could sub in 0, 0 right at the end. So their value that they came up with was -2. And then that gets subbed in right here. Your constant may not have been -2, though, but your equation should be the same. So this, we've got 2 for our this is, the 2 that ended up moving over here when you solve for y. The -2 ended up being your coefficient out front, and then we have e raised to the 1/5 x to the 5th. Solving for y was a point, and then it said immediately if you don't make y exponential, you can't get the point, which makes sense. I don't know why they felt the need to like specifically say that, because if the equation is wrong, you don't get the point. So I don't know why they felt the need to specifically mention the exponential equation. All right, any questions on this one? Okay. The whole plus or minus thing with your constant, I told you guys it would get taken care of. It ended up being a -2 rather than a +2, but like I said, just plug in the initial condition. You'll end up figuring out whether it's the positive or negative one. Okay, and our last one was on the next page. We need a little bit of unit circle knowledge here to get our slope fields correct. So you can see the setup is the exact same. Part B is something weird, but A is always the same with 2 points. C is always the same with 6 points. So for part A, you get a point for having these 3 slopes equal to 0, another point for all the other slopes. That means if one of them is wrong, then you don't get that additional point. Okay, so we should have, alternating kind of, these look like ones, I think, but negative, positive, negative, and then we've got some alternating slopes here. So pay attention to the steepness, pay attention to the direction. B is just an answer. There's no explanation. It doesn't say anything about showing your work. So if you look at the slope fields and you're like, oh, that looks like a horizontal line, 1. Or like if you actually set the derivative equal to 0 and solved for that, that would work too. But it's saying that there is a horizontal line. A horizontal line means the slope is 0. So you could have either noticed something that seemed to be a horizontal line when you were looking right at your slope fields, or if you set the differential equation equal to 0, you would have come up with y equals 1 that way. Okay, and then part C, I'm guessing we didn't quite get to this point yesterday, so I'll have you guys kind of go through this and write everything down. So the separation of variables is the first step. I don't know why their pi's look so weird. So the y minus 1 squared would go as an entire quantity off the left-hand side. And remember, writing the negative second power is totally fine. The cosine of pi x stays on the right. So the antiderivatives are a little bit tricky with this one because they both technically have a nested function. Y minus 1 is a nested function, but because its derivative is just 1, you didn't have to do anything fancy with that. So the power pops up to -1. You divide by -1, so the left-hand side on that second line is negative, and then y minus 1 raised to the negative first power. That 1 over pi, let me show you. So there's two ways that you can think about this. If this nested function is just something linear, you can just know that like doing a derivative chain rule, you'd multiply by pi. So doing an antiderivative chain rule, you'd divide by pi. Just kind of knowing that that would happen, you could know that the 1 over pi was going to be here. Or you could do a u substitution and say that u is equal to pi x, which means that du is equal to pi dx. And then to sub out the dx, you would have a 1 over pi du. And that's like in a very formalized way where the 1 over pi comes from. But if you just know like, oh, there's a nested function, I'm going to have to divide by the nested derivative. Like if you do that without a u substitution, that is perfectly fine. But here's formally where that 1 over pi came from. So then you could think of this as like the antiderivative of cosine u, then this would be sine u, and it would have a 1 over pi out front. So this next line, they just rewrote this right here. What they did is they took the negative sign and they distributed it to the y minus 1 and they made it 1 minus y instead. You could definitely just leave the -1 in the numerator if you wanted to do it that way. You could multiply the negative over to the other side. This is always just kind of one option of how they got to the final answer. If your final equation is right, then you're good. So then the next thing that they did is they subbed in at this point and got the value of c. So the initial condition was 1, 0. So a 1 went in right here for x. So it left us with just a pi. And then when this 0 went in for y, it became 1 over 1. So the left-hand side was just 1. So solving for c, 1 over pi times the sine of pi. Knowing your unit circle will tell you that the sine of pi is just 0. So 1 over pi times 0 is 0, plus c would be c. So they just solved for c in this step and found that it was 1. So then this c right here got replaced to the 1. So this fifth line right here is just the same as the third line, except we replaced the c with a 1. So then a couple steps here, it looks like they did a little bit of cross multiplying. So they took this 1 over pi, multiplied both sides by pi. So they ended up with a pi over here. And then they did a couple steps without really showing them. So it looks like they did some kind of cross multiplying here. So if you cross multiply, it would put the 1 minus y over on the right-hand side here, and it takes this entire side and moves it underneath the pi. So kind of missing a step, they would have pi over sine of pi x plus pi equals 1 minus y. So like that's what they did from this step is they cross multiplied, sort of cross multiplied and divided this over onto the other side. So this, which was over here, became the denominator under the pi. This, which was under here, multiplied out over on this side. So then they did kind of a couple more things at once. Then they subtracted the 1 over to the other side and then divided by the -1 that was attached to the y. I don't know why they felt the need to write that the domain was all reals. They normally only write the domain if it's not all reals. So I wouldn't worry too much about this part of it right here. Not sure why they did that. Okay. I'm assuming we didn't get through most of this. So do you guys have any questions as you're going through and writing this down? Okay. So knowing how to do the slope fields, knowing how to do the differential equations, both super important for tomorrow. I am going to flip the screen up to what we have on